In this video, our robot will gradually slow down so that the stopping position is precise. Our robot will stop a certain distance or set point from the obstacle. We will not be using a state flow chart in this video. We begin by dragging an ultrasonic sensor block from the VEX library. Next, we need to determine the distance from the obstacle that we want to stop. Again, we call this distance the set point. We use a variable block which can range from 0 to 2 meters, which is the range of our ultrasonic sensor. Then, we will set our set point to 0.3 meters. Next, we need to determine the difference between our set point and our sensor reading. We call this the error. We can do this by using a subtraction block. The magnitude of the signal to the motors is proportional to the value of the error. The value of the error is multiplied by a factor we call the gain. This is why we call this a proportional controller. At this point, our model of a proportional controller is complete, and we could deploy this model to our robot. We will now add several blocks so we can simulate the actions of our robot. A display block allows us to view the value of the error. We can use a variable input block to simulate the sensor reading of a distance from an obstacle. We will need to activate the simulation input port from the block parameters on our ultrasonic sensor block. We can now determine the range of values for our distances for our simulated input. This allows for a constant simulated input. We can use a display block to monitor the value of the motor speed. Next, we will use the scope so we can make a graph of the motor speed versus the distance. If we drag a scope block from our VEX library and we open up the parameters and allow for 2 inputs for our scope. Next, we will connect a signal line from our motor block to our scope block. If we want to continuously vary the simulated input into our ultrasonic sensor block, we will need the ramp function, which we can find in the library browser. By entering ramp into the library browser, we can drag a ramp block onto our Simulink diagram. We can now connect the ramp block to our ultrasonic sensor block. This will allow us to simulate a continuously varying input. We also want to connect this to our scope so we can see a simulation of this. If we run the simulation, we can see a graph generated by the scope of both the ramp function and our motor speed. If we deploy this model to our actual robot, we can see that the robot motor speed decreases as the robot approaches the set point.